Okay, so I have another one. Suppose I have two IID standard normals and I add and subtract them to get a transformation. This is a one-to-one transformation, and we can apply the formula above to find the joint PDF of U and V. So let's just do this. So we need, yeah, I did this ahead of time. So U is the sum, V is the difference here, and I found the functions that bring me back to X and Y. And now we just, yeah, we need J, I guess. So J is equal to the determinant of, okay, my X function, my H1 with respect to U, that's a half. With respect to V, that's a half. Y with respect to U, that's a half. With respect to V, it's negative a half. And so I get negative a quarter minus a quarter, so that's negative a half. So I'll take the absolute value of that in my joint PDF. So F UV right? And in here I put 1/2 times 1/2, the absolute value of J. Okay, and since these are independent, it's just the product of the marginal distributions. So this should just be standard normal. This is true on all of R2. It's defined, the support is all of R2. So we have 1 over square root 2 pi here, and then I have e to the minus 1/2. This squared, so I'm going to get an 8th here, actually minus 1/8 u plus b squared. I think that's it, right? That's right for the first one. The second one will look the same, only have a minus sign here. So 1 over square root 2 pi e to the minus 1/8 u minus b squared, and then let's not forget we'll need this 1/2 here. Okay. How can I simplify this? This is it. You're done, really, but we want to simplify this at this point. We'll see why when we get to the end. So we can simplify this, right? The cross term is going to cancel, the minus 2uv and the plus 2uv. When I square the two sides here are going to cancel out. And I just get this in the end. I get I'm going to keep this here for some reason. So e to the minus u squared over 8 times 1 over square root 2 pi e to the minus v squared over 8 times 1/2. You see why? Oh, hold on. Did I screw it up? It should be over 4, perhaps, right? I get u, the thing I skipped over, right? I messed up. So it's u squared plus 2uv plus v squared here. U squared minus 2uv plus v squared here. And so when I add this together, these become fourths, right? In other words, I have 2u squared here when I do this, 2v squared and a 0. And so this looks right. All right, well, we've separated these. This is the thing. Through that cancellation, we see that we have a product of marginal PDFs. Now, you're really done here. You know that U is normal and V are normal and that they're independent now. So independently, so we know they're independent. We just want to check, though. We want to finish this and identify the marginal densities. So you can see you just need to split this half equally in here and in here, and it should come in here as a square root of 2 in each piece, right? So I have 1 over the square root of 2. So that would be square root of 4 pi e to the minus u squared over 4 times. Okay, and that's for all uv in R2. Notice, what is this distribution? Well, it better be mu is 0, so it's certainly normal. Mu is 0, and the variance has to be here. This is 2 sigma squared here, so sigma squared has to be 2. This also is correct, right? That's all I was checking, really, is because this is 2 pi sigma squared, and this is also correct. So yes, so we see u and v are independent, or we can now write it this way: x plus y is normal 0, 2. We basically knew that at the start. X minus y normal 0, 2. But the interesting part is they are independent. You wouldn't think, right? You wouldn't be sure anyway. Okay, I have 2 more to do. One develops, and one gets into our sufficiency discussion and likelihood discussions. So that's one of the motivations for doing this, but it's going to be used also for other stuff. So I think we'll just put those on the homework or do them in the lecture tomorrow. So this will do it for the videos on bivariate transformations, I think. All right.